So welcome to Everyday Mathematics. Here at Everyday Mathematics, as we always say, we do enjoy solving the harder problems, but above all, we do also appreciate and see the beauty in the simpler problems. Today, our focus shifts to the MIT 2024 Integration Bee Semifinals #1 Tiebreakers set of problems. And we are going to look at the problem #1 in the tiebreakers of the semifinals #1. The problem will be this indefinite integral of secant to the power 5 x. So this is a very interesting problem. Now, before I jump into solving this problem, I'd like to thank our subscribers. Thank you so much for your support. We really don't take your support for granted. We do appreciate the support you give us. It is a motivation that keeps us going and just allows us to come here time and again. I also like to thank our first-time visitors here at Everyday Mathematics. What we do is we just go about and around and look for these seemingly harder problems. Somehow we've just kind of locked in the MIT Integration Bee set of problems, but our interest goes far and wide. So after looking at these problems, we come back with solutions that we think befit these problems, and then we share out with you. For repeating visitors, I would like to encourage you to consider subscribing if you've not subscribed. So how would we solve this problem? Secant to the power 5 of x. First of all, I think what could be of interest is when you look at secant to the power 5x, if you differentiate tan x, for example, you get sec squared x. Now that times sec cube x becomes sec the power 5x. So that kind of is a hint. So how I would begin the process is I would differentiate the product of sec cube x and tan x, where you have, obviously you differentiate one component and then you add the product of the other component differentiated, okay? So for example, here we have, I would have tan x, the derivative of sec cube x, plus sec cube x plus derivative of tan x. And this becomes tan x 3 sec squared x times the derivative of sec x, which is going to be, we're going to find out that later. And then here we have sec cube x times sec squared x, which is the derivative of tan x. And so sec x, when you differentiate, is sec x tan x. So eventually we have 3 sec cube x times tan squared x plus sec to the power 5x. What this means is that when you're integrating sec to the power 5x, that's the same as the integration of the derivative of sec cube x tan x minus the integral of this component, right? So since we're integrating the derivative of this, that is the same as just sec cube x tan x minus 3 sec cube x tan x squared, right? So this here is obviously a move in the right direction. And then now we know what tan squared x is. Tan squared x is the same as sec squared x minus 1. So if we substitute for tan squared x with sec squared x minus 1, what we get essentially is sec cube x tan x minus 3 sec to the power 5x minus sec cube x. Now this here, the entire integration is the same as what we have on our left-hand side. So we can just move this by adding 3, the integral of sec to the power 5x on both sides. So we get 4, 3 plus 4, 1 here, we get 4. The integration of sec to the power 5x being equal to sec cube x tan x plus, because we have this negative and this negative here, plus 3 sec cube x. Okay, we're progressing. Then the next stage is obviously we can divide both sides by 4 so that we remove that constant on the left-hand side. And so we have the integral of sec to the power 5x being equal to a quarter sec cube x times tan x plus 3 over 4, the integral of sec cube x. Now, our focus now is going to shift here. Sec cube x integral or integrated is the same as sec x times sec squared x. Now, sec squared x is the same as tan squared x. This here is plus 1. Yeah, sincere apologies. So we have the integral of sec squared, sec x tan squared x plus the integral of sec x. And now, again, we have to focus here. This part here, we're going to try to do some little acrobatics here. So the derivative of sec x tan x, since we see this squared here, if we try to differentiate sec x tan x, it's the same process. It's the same as sec x times the derivative of tan x plus tan x times the derivative of sec x. And so we have sec x times sec squared x, which is the derivative of tan x, plus tan x. When you differentiate sec x, we get sec x tan x. So we get sec cube x plus tan squared x times sec x, which is very similar to what we have here. Now, when we integrate tan squared x sec x, in other words, when we integrate this, the same as the integral of what we have on the left-hand side here, the derivative of sec x tan x minus the integral of sec cube x. And so since this is the integral of a derivative, we just get the same thing as sec x tan x here, minus the integral of sec cube x. Now, if we plug this here, we get sec tan x here minus sec cube x. We say this was plus the integral of sec x. Now, this here is the same as what we have on the left-hand side. So when you bind things together, we get 2. The integral of sec cube x is equals to this sec x tan x plus the integral of sec x. Okay, so we're making progress. Now we're going to divide both sides by 2 to remove this 2 on the left-hand side. We again say this was plus. Now, the integral of sec cube x now is the same as half sec x tan x plus a half sec x. Now, since we know that the integral of sec to the power 5x is equals to a quarter sec cube x tan x plus 3/4 the integral of sec cube x, we can now plug everything here into what we have here, the green, right? And so we have sec to the power 5x integral being equal to a quarter sec cube x tan x plus 3/4 a half sec x tan x plus a half the integral of sec x. And so we have a quarter sec cube x tan x plus 3/8 sec x tan x plus 3/8 the integral of sec x. And this is now what we're going to focus on right now. For me, I really enjoy integrating sec x. So this is also going to be really, really fun. So let's see. Sec x integral is the same as 1 over cosine x. Now, cosine x using the half angle formalism is the same as cosine squared x over 2 minus sine x, sine squared x over 2. Now, the interesting thing is, since this is the difference of two squares, this is the same as cosine x over 2 minus sine x over 2 times cosine x over 2 plus sine x over 2. And so we can also add a constant half here so that we keep constant 2 in the numerator. Now, this is the same as twice cosine squared x over 2 plus sine squared x over 2, so that this is 1. And then obviously distribute the constant 2 across, so it's 2 cosine squared x over 2 plus 2 sine squared x over 2. And now, because we have a 0 here, we could say this is the same as minus 2 sine x over 2 cosine x over 2 plus 2 sine x over 2, so that this would cancel and get a 0. And then obviously the identity of this plus this being equal to 1, and then times 2, we get back this 2. So just doing some acrobatics here. And so we have a half, and then we can bunch the first cosine squared x plus sine squared x over 2 with the plus 2 sine x over 2 times cosine x over 2, and then plus the second cosine x squared x over 2 plus sine squared x over 2. Then we bring the minus 2 sine x over 2. Now, this is interesting. So we can now distribute things in the numerator, because this is the same as cosine x over 2 plus sine x over 2 squared. So just, and then this is the same as cosine x over 2 minus sine x over 2 squared, right? Now we can just split that numerator so that we have this first half with the same denominator, the second half with the same denominator. Okay, so what we're going to see here eventually is that this cancels out with this. And then what happens here is that since we have cosine x over 2 minus sine x over 2 twice, so this would cancel out with this, right? And so here we are left with half the integral of cosine x over 2 plus sine x over 2 over cosine x over 2 minus sine x over 2. And then here we have cosine x over 2 minus sine x over 2 over cosine x over 2 plus sine x over 2 integral. So as you can see, we're going to play a little bit farther here. This numerator on the first integral here is the same as negative twice the derivative of the denominator, right? Because when you differentiate cosine x over 2, we get negative a half sine x over 2. And then, I mean, when you differentiate this denominator, cosine x over 2 differentiated is the same as negative a half sine x over 2. And then you differentiate, this is the same as negative cosine x over 2 times a half. So essentially just the same thing you have in the numerator, but multiplied by 2 and then also times negative 1. So essentially now we have a half the integral of negative 2, the derivative of cosine x over 2 minus sine x over 2 over our same denominator. And then here, as you can see, the numerator is the same as just twice the derivative of the denominator, right? Because this negative sine x over 2 comes from differentiating this cosine x over 2, then multiply by 2. And then when you differentiate sine x over 2, since the sign doesn't change, it just becomes cosine x over 2, but obviously multiplied by 2. So what we see here is that now we can use the natural logarithm. So this is a half negative 2 natural logarithm of cosine x over 2 minus sine x over 2 plus cosine x over 2 plus 2 natural logarithm of cosine x over 2 plus sine x over 2, and then obviously integration constant. So this half here goes with that and that. And then obviously using the rules of logarithm, when you have a minus, you definitely divide whatever is under the log function. So we have cosine x over 2 plus sine x over 2 divided by this cosine x over 2 minus sine x over 2. Next thing is I would like to just multiply both the numerator and denominator with cosine x over 2 plus sine x over 2. So when you do that, just multiplying by the same thing so that this would cancel out, but still giving you the same thing. So what this leads to is cosine squared x over 2 plus 2 sine x cosine x over 2 plus sine squared x over 2 divided by cosine squared x over 2 minus sine squared x over 2, because this is just the difference of squares, two squares. Then bunching this and this becomes 1, obviously. Just bunch them together, the famous identity. And then 2 sine x over 2 cosine x over 2, this is the same as sine x, right? And this here is the same as cosine x, right? So when you simplify things, you get 1 plus sine x over cosine x. And so you divide this numerator's components independently. We get sec x plus tan x, and then the integration constant. Now, since we know that the integral of sec to the power 5x is the same as a quarter sec cube x tan x plus 3 over 8 sec x tan x plus, remember this is 3 over 8, the integral of sec x, we would say then, by plugging in what we found as the integral of sec x, that the integral of sec to the power 5x is a quarter sec x tan x plus 3 over 8 sec x tan x plus 3 over 8 natural logarithm of sec x plus tan x, and then the integration constant. So my friends, thank you so much for hanging out with me in this quest for such a wonderful answer. I hope you had fun following along. If you have any question, please feel free to just leave a comment in the comment section. Or if you have an alternative solution, we're here to learn from one another. Please feel free to leave that suggestion so that we all learn from one another and make this wonderful community that we all desire. Thank you so much. Until next time, Dios. It was good hanging out with you.